Hey folks, Lecturer Joe here, and welcome to the first and most important lesson in electrical engineering. Even if you don't know anything about electrical engineering, you've probably heard phrases like this: volts, amps, resistance, AC, DC. Well, the good news is that we don't need to think about any of that at this stage, because we need to start at a much more fundamental level, and none of these ideas are relevant. The first thing we got to consider is how electricity flows, and the best analogy for that is something that you're already familiar with, which is simply water flowing in a pipe. So here we've got a water tap, and when we turn on that water tap, we get a flow of water out of the tap, and this water is flowing out at a certain rate, and this flow rate would be measured in something like liters per second. So if we put a bucket underneath this tap, and let's imagine it's a 10-litre bucket. If we find that the water level in this bucket goes from 0 to 10 litres in 5 seconds, so it takes 5 seconds to fill the bucket, that means that we have a flow of 10 litres in 5 seconds. So the flow rate is 2 litres per second. Now, in everything that we're going to be looking at here, before we get on to our electrical engineering, the important idea is this: the flow rate. We know that this bucket can hold 10 litres. We've got water flowing out of this tap. It takes 5 seconds to fill a 10-litre bucket, so in the space of 5 seconds, 10 litres has flowed through the tap, 2 litres every second. Okay, now let's imagine we connect a hose pipe onto our water tap. Now when we turn the water tap on, the water is going to come out of the hose pipe here and fill our bucket just like it did before. And let's imagine further that it still takes 10 seconds to fill the bucket. Sorry, 5 seconds like it did before to fill the bucket. So we're filling a 10-litre bucket in 5 seconds. So the flow rate out of the end of the hose here is still got to be 2 litres per second. So every second, 2 litres of water falls out the end of this hose into the bucket. If we then ask the question, what's the flow rate here? Out of the tap and into the hose pipe, I'm hoping you can see that that's also bound to be 2 litres per second. 2 litres per second flows out of the hose into the bucket. 2 litres per second is flowing out of the tap into this end of the hose. So the flow rate here, out of the tap into the hose, is also 2 litres per second. Easy enough, so far so good. Now something interesting happens. Someone comes along and stands on top of this hose pipe. And while they're standing on the hose pipe, we notice that the flow rate out the end of the hose pipe has got lower. It's now taking 10 seconds to fill the bucket. So a 10-litre bucket is taking 10 seconds to fill it because the flow rate here has reduced. So the flow rate out the end of the hose, 10 litres, 10 seconds, is now just 1 litre every second. 1 litre per second. That's straightforward enough. The interesting question is, what is the flow rate here? Now think about that for a moment. We've got a 10-litre bucket filling in 10 seconds, so the flow rate here must be 1 litre per second. every second 1 litre falls out of the end of the hose into the bucket. Here we used to have a flow rate of 2 litres per second. Now we're not so sure. So now that someone has stood on top of the hose, the question is, what is this flow rate? Now whenever I pose this question in class, I usually get two different answers. Some students say the flow rate here is still 2 litres per second, because after all no one has touched the tap. We've just someone stood on the hose further down the line, but nothing has changed up here. Other students say it's now only 1 litre per second. So we usually end up with a split of opinion as to which of these is the correct answer. And one of them is the correct answer. Have a think about it. If you like, you can pause the video at this point and decide which side of this argument you're on. Okay, let's try and figure it out. So let's assume that this is the correct answer. Let's assume that having stood on the pipe, there's 1 litre per second flowing out the end of the pipe into the bucket, but still 2 litres per second flowing out of the tap and into the pipe. Well, what would this mean in practice? Well, 1 litre every second means that in the space of 1 hour we would have 3,600 litres, which is about 3.5 tonnes of water. So in the space of 1 hour, about 3.5 tonnes of water falls out the end of this hose. If the flow rate from the tap into the hose is 2 litres per second, that means that 7,200 litres, or over 7 tonnes of water, have left the tap and gone into the hose. Now think about it. Let's say it's 4 o'clock in the afternoon. By the time it gets to 5 o'clock in the afternoon, 1 hour later, 3.5 tonnes of water have come out here, but 7 tonnes of water have gone into the hose. So that kind of leaves the question, if 7 tonnes of water go into the hose and only 3.5 tonnes come out, where did the other 3.5 tonnes of water go to? So we have a problem there. Clearly it can't simply disappear from the universe unless the pipe had some sort of leak in it, perhaps, which it doesn't. So the answer here is that this cannot be correct. Whatever the flow rate is out the end of the hose, it must also be the same flow rate here. Over the period of an hour, if 3.5 tonnes of water fall out the end of the hose here, it can only be because 3.5 tonnes of water have left the tap and gone into the hose here. A flow rate of 1 litre per second here means a flow rate here of 1 litre per second. This is the only possible answer. And what this means is that when you stand on the pipe and you reduce the flow rate here, you in fact reduce the flow rate at all points along that pipe. Even right back to here, the flow rate from the water supply into the tap is bound to be 1 litre per second. So what this means is, if there is only one pipe and there are no leaks in the pipe or no connections to other pipes or anything like that, then the flow rate has got to be the same everywhere along the pipe. And because electricity flowing in a wire behaves in much the same way as water flowing in a pipe, when you have a wire with electricity flowing in it, the flow rate along that wire is going to be the same at all points along the wire, as long as again that there are no connections in the wire to any other systems. This is the most important and the most fundamental idea in electrical engineering, so you gotta always remember this. In the next video we'll see where this takes us when we start to look at electricity instead of water.